Good morning, students. This is Latif sir. Today in this video I am going to start the third chapter of class 11th chemistry. The topic is classification of elements and periodicity or periodic property, periodicity in properties. Chapter 3. The topic is classification of elements and periodicity in properties. In this chapter you have to read mainly about modern periodic table and modern periodic law. So first see the modern periodic law. You have already studied in class 10. According to the modern periodic law, the physical and chemical properties of elements are periodic function of their atomic numbers. According to modern periodic law, the chemical and physical properties of elements are periodic function of their atomic number. So the modern periodic table is based on atomic number. Okay, this is the modern periodic table. You have already studied to some extent in class 10. Okay, now see the structural feature of the long form of the periodic table, a structural feature of modern periodic table. Okay, so on the basis of the modern periodic law, a scientist named Bohr proposed a long form of periodic table that was prepared by Rang and Warner. And now see the structural features of long form of the periodic table. It consists of 18 vertical columns, which are known as groups, and the modern periodic table consists of 7 horizontal rows, which are known as periods. So, in modern periodic table or long form periodic table, there are total 18 groups and 7 periods. And elements of group 1 to 13 to 17, group 1, group 2, and group 13 to 17 are known as representative elements. And elements of group 3 to 11 are known as transition elements of group 3 to 11. And group 40, and next one, the 14 elements with atomic number 58 to 71, that is from cerium to lutetium. Cerium to lutetium, these 14 elements are known as lanthanides or rare earth element. Okay, so 14 element with atomic numbers 58 to 71, that is cerium to lutetium, are known as lanthanide element, and these are placed at the bottom of the periodic table. And 14 elements with atomic number 90 to 103, that is 90 means thorium to lawrencium. The 14 elements with atomic number 90 to 103, that is thorium to lawrencium, are called actinides element, and they are also placed at the bottom of the periodic table. And the 11 elements with atomic number 93 to 103, that is neptunium to lawrencium, these 11 elements which occur in the periodic table after the uranium and have been prepared from it by artificial means are called transuranic elements. Okay, so these elements are, that is neptunium to lawrencium, are known as transuranic, and all these transuranic elements are radioactive in nature. Next point, the elements belonging to a particular group are said to constitute a chemical family which is usually named after the name of first element. For example, boron family is known as group 13 because boron is the first element of group 13. Carbon family, that is group 14, because carbon is the first member of this family, of this group 14. Nitrogen family, that is group 15 family, because nitrogen is the first member of this group. Oxygen family, group 16 family, is known as oxygen family because oxygen is the first member of this group. Okay, and in addition to this, some groups have some typical names. For example, group 1 elements are known as alkali metals. Group 2 elements are known as alkaline earth metal. Okay, and group 16 are known as chalcogens. Group 17 are known as halogens, and group 18 elements are known as noble gases. And the long form of the periodic table contains 7 period, okay. Now I'll describe about the periods. So there are 7 periods, and period 1, that is first period, which contain hydrogen and helium. First period contains hydrogen and helium, that is only 2 elements are present in first period, and this is the shortest period of the periodic table. Second period, in which there are 8 elements are present from lithium to neon. And in third period there are also 8 elements from sodium to argon, okay. So third period and second period are known as short period. In both period 8 elements are present. In fourth period, from potassium to krypton, and fifth period, from rubidium to xenon, contain 18 elements. So fourth and fifth period contain 18 elements, and these are known as, these 2 periods, that is fourth and fifth period, are known as long periods. And sixth period, from cesium to radon contain 32 elements and is the longest period. And seventh period, which is a incomplete period, okay, which contain only 24 elements. Now see another classification of periodic table. So another classification, the long form of periodic table has been divided into 4 blocks, that is S block, P block, D block and F block, depending upon the subcell to which the last electron enters. So in another classification, the long form of the periodic table has been divided into 4 blocks, SP, DF block, depending upon this half cell to which the last electron enter. So SPDF classification. So first one is S block elements, group 1 and group 2, that is alkali metals and alkaline earth metals, which are respectively have electronic configuration NS1 and NS2, and these two groups are known as elements of group 1 and group 2 are known as S block elements, and their outermost electronic configuration, the general outermost electronic configuration of S block elements is NS1 to 2. In case of group 1, the outermost electronic configuration is NS1, and in case of group 2, the outermost electronic configuration is NS2. Now P block. Now see P block elements. In P blocks, that is group 13 to 18, elements are known as P block elements, 13 to 18, and their outermost electronic configuration is NS2, NP 1 to 6. NS2, you have to remember the outermost electronic configuration of each block, okay. So P block elements, they have general outermost electronic configuration NS2, NP 1 to 6. Now see, here one point is given, one note: helium, whose electronic configuration is 1s2, is a S block element, but helium is positioned with the group 18 element having general electronic configuration NS2, NP6, okay, because it has completely filled valence shell, and as a result exhibit properties characteristic of other noble gases. So due to similarities with noble in chemical properties, helium is positioned in the group 18 with noble gases, okay. And now next, D block element or transition element. These are element of group 3 to group 12, okay. D block element group 3 to group 12, having outermost electronic configuration of D block element n-1, D1 to 10 and ns1 to 2. The general electronic configuration of D block element is n-1, D1 to 10 and NH2. This is the general electronic configuration of d block element, you have to remember. And 4 transition series are there, and 3D series, 4D series, 5D series, and 6D series. And now see F block elements. F block elements, these are also called inner transition elements. F block elements are also called inner transition elements. Lanthanide and actinides are known as F block elements or inner transition elements. Okay. Lanthanides characterized by filling of 4f orbitals. And lanthanides elements are from cerium to lutetium, atomic number 58 to 71. And actinides are characterized by filling of 5f orbital. In actinides electrons, the last electron enter into the 5f orbital, and in case of lanthanide, the last electron enters in the 4f orbitals. And actinides element starts from thorium to lawrencium, that is atomic number 7 to 110. Now characteristic general outermost electronic configuration of lanthanide and actinide, that is uh, F block elements, which is n minus 2 f 1 to 14, n minus 2 f 1 to 14, n minus 1 d 0 to 1, nh2. This is the general outermost electronic configuration of F block element, n minus 2 f 1 to 14, and n minus 1 d 0 to 1, and nh2. And noble gases are present in group 18. Okay, so gaseous element of group 18 are called noble gases, and general electronic configuration of noble gases except helium is NH2 NP6. This is the general electronic configuration of all noble gases, okay, except helium. Helium has 1s2 electronic configuration, and thus the outermost shell of noble gases is completely filled, and thus noble gases are chemically inert. They do not react with any other element because they have stable electronic configuration. Okay, so you have to remember the characteristic of different groups and periods, and different blocks, S block, P blocks, and their electronic configuration, general electronic configuration of S block element, P block element, D block element, F block elements. Okay, thank you students.